Yum, yum!
Greg here from Pixel Fondue, and this big ball of string was modeled in MODO with the help of array nodes. Now, array nodes made an appearance in MODO 13, and if you're like me, you watch the videos and you're like, oh, interesting, you can manipulate numbers and a list of things and do things with it, I guess. And then you just kind of moved on and didn't ever touch them again, or even touch them once. So I was like, you know what? I'm gonna mess around with these a little bit, and I'm gonna model something that you wouldn't be able to sort of model traditionally very easily. And so this big ball of string is one thing, and if you zoom in here, this is actually rendered at 8K. One thing you'll notice is it really doesn't intersect. It does a couple of places. I think well, maybe here's one, or maybe there's one or two other places on here where it's noticeably intersecting if you really look. But you could conceivably make this with the string never intersects itself ever. Oh, here's one that sort of looks like it is. But that's just because I didn't really do the math on it. I just sort of winged it. But the concept behind this, you'll be able to create objects like this without this singular curve ever intersecting itself. And this was created very simply with a couple of keyframes and arrays. And I'll show you how I did that. Here it is as copper wire, a big ball of copper wire. This actually has a bit of a noise displacement on it from the really fine kit Tracer X, Particle Tracer X, or just Tracer X from Mario Baldi. That you should definitely buy and have. It's super useful. And this also has a couple other nodes just to make it a little more dense, so I didn't have to render a curve with 800 quadrillion grillion polygons. I'll show you how to do that as well. This ball of string is supposed to look like spaghetti. I don't know. Maybe. Does it? Kind of does, doesn't it? Rendered in Octane. Looks a little bit like spaghetti. That's one thing to make. And the second thing we're going to make is this. And so this is actually a really interesting technique. This 3D head here is wrapped with a single curve from the bottom here all the way to the top of the head. It's a single unbroken curve, and this is supposed to look kind of like fishing line. And I also made a spaghetti one. And then I kind of went crazy and made a kind of a ramen noodle one, maybe? I don't know. And again, this is using just a noise displacement from Tracer X, and then using one of the built-in gradient nodes. And because it's just a single unbroken curve, there's no displacement at 0 and maximum displacement at 100 here. So you can do stuff like that. Or even draw this, animated drawing on the entire time. It's really pretty cool what you can do with it. Here's just another angle of that same head. I could push in a little bit since it was rendered at 4K. And yeah, I mean, it's a pretty cool technique. And again, it creates art that you wouldn't otherwise model by hand. Something MODO is really used for and kind of famous for is its fantastic ability to sort of just whip things up by hand and using the talent of the modeler and the power of the interface. This is using some procedural techniques to create items and objects that you would not really want to model by hand. So that's where we're going to go with this tutorial. So here we are in MODO. I've made the background just this blue color because I think our curves that we're going to be making will show up against it a little bit nicer. And let's just do a quick intro to arrays really quickly. So I'm pressing L to add a locator to the scene. You can also just add it from the item list here if you want to. And in fact, I'm going to press L twice and have 2 locators. And then the second one, I'm just going to move above the first one. And I think I'm going to give these guys a shape real quick. That's not just that standard one, so they show up a little better. So I always use, almost every tutorial I do, I'm always bringing out the Ateria Quick Locators kit. You should have this. If you do not have it, you should have it. So I'm just going to make these guys spheres, and I'm going to make them, I think, green. And I'm going to make them a lot smaller, and then maybe a little bit bigger than that. Maybe like that. So there's my 2 locators. And let's pop open the schematic. We'll be using that a lot. And with both locators selected, we can add them to the schematic. I don't need this anymore. And then let's add an array node. So under add, under this new category, MODO 13, we have this array category. And we have all these array nodes here. And these are different nodes that let you create arrays, manipulate arrays, do all kinds of stuff with arrays. And we're just going to get the locators to array. And that's just exactly what it does. It creates an array is just a list, right? That's the best way to think about it. It's going to create a list from these locators. So I plug in these locators, it's making a list. In fact, if I have this selected, you'll see if I sort of pull out. It's kind of hard to tell because I made these circles, I guess, but there's a 0 on this one, and there's a 1 on this one. So it just made a list, 1 and 2. Pretty simple. So I unplugged the second one. I can also, I've got some options over here in the properties, and right now it says multiple, and that's an array making, or this node making an array out of multiple locators. But if you turn it to single, what it's going to do, it's going to make a list or an array out of the locator's position on every frame. So if I, on frame 1 here, if I hit, make sure I'm in item mode and have this selected, if I hit Shift W, I get a keyframe on frame 0. I go up to frame 210 or whatever your scene is at and drag out. You see this whole list happening here, right? 0, 1, 2, 3, 4, 5, 6, 7. So it's making a new entry into the list at every single frame. And if you look over here, there's a, on this array node, there's a end time. Let's put that to 210. So it goes all the way to the end of there. And so there's a list. In fact, I can just duplicate this guy and plug in, unplug that, and plug in my second locator. And if I animate this one, Shift W, and then maybe at the end, I'll put it over here just above it, and maybe in the middle, I'll move this guy down, and maybe in the middle, I'll move this guy up. So we can look at these. So we've got a couple different arrays going on here. Whoops, let me see. I don't think I'll move this guy down, back down here. There we go. So there's 2 arrays going on right there. So we have 2 lists, right? And so we can also manipulate these lists with some other nodes. So if I take like an array blend node and input these guys in input A and input B, now I've got an even bigger list. So it's doing a 10 count between these, is blending the values of each item in the list, right? Each position. So it's blending between these 2 locators at position 0, 10 times, at position 105, 10 times, at position 210, 10 times. You know, I can adjust this to whatever I want. I could even remap it with this gradient, which is cool. And if you have, 13.2, if you're watching this when 13.2 is out, you'll be able to add all kinds of, gradient operations to the gradient and do all kinds of other things with it. But so, I'm just manipulating these lists of numbers. That's all I'm doing. And ultimately what you can do with these lists is I can take my mesh here, and I'll just call this geometry, and add this to the scene right here. And then I can add a mesh operation to it. Let's add a create polygons mesh operation. There it is. And the create polygons is looking for an array, it's looking for a position array. So I could plug in this blended list here. And now it looks kind of weird right now, but I've got some options over here with create polygons. Right now it's just set to fill. But if I change this to, well, actually let's keep it fill now. But if I change it from face to curve, what I've got now is 4 curves. You'll notice that they're closed, so I can also make it an open curve like that. So now I've got 4 curves based on the position of these locators, right? Or their animation positions, or the animated positions of these locators. And you can do things like, you can actually bridge these guys, like that, and bridging the curves, or I could change this to face, and I've got a bridged face. So I'm doing procedural bridging based on this animation, So if I change the animation, then it's going to change this, shape of this output here, this bridged polygons, or these curves, or whatever we want to turn those into. So you can kind of see where I'm going with this. We can create geometry with just animated locators, and by sampling them, creating a list of their positions, and then feeding that into this create polygon node, and just drawing a curve along those positions. So it's pretty cool. So that's what we're going to do to create this big ball of string. So why don't I delete all this stuff. In fact, I'll keep my create polygons right here. We'll just keep that. And actually, let me undo that. I'll keep this locators to array as well. So let me delete these other 2. And I'll just unplug this for now. We'll get back to that in a second. So I've got 2 locators. We'll name this first locator, we'll just call it X, and the second locator we'll call it Y, and duplicate that guy, and this third one we'll call Z, and then we'll duplicate that, and we'll call it endpoint, how about? Or, yeah, endpoint is fine. It's explanatory. And actually, let me just grab these guys while I can, and clear off all the animation here. So I just remove all, go back to 0. And so no more animation on these guys. I don't really need this mesh op list open anymore. And then I'm going to do a couple more things. I'll take my endpoint 1, and then I'm going to move him to 0.5 like this on X, so just moving them out there to 0.5. And then these X, Y, Z ones, I'm gonna actually change the shape so it makes a little more sense. I'll bring back my quick locators guy again, and we'll make them all planes, and we'll make it red, and we'll make it 0.1 and 0.1, and then not solid, and then I'll just actually change the Y1 to green and on Y, and the 0.1, and the Z1 to blue, and we'll make sure that is on Z, and then make that 0.1. Okay, so we've got an X, Y, Z locators there, don't need the grid, and we've got this end 0.1. And then I'm going to press N for just a new empty mesh item. And this guy, we'll just call it sphere. I'm going to create a procedural sphere in here. Just go add, whoops, those are images. Let's do a add operator. We'll do a sphere operator like that. And keep it at 0.5, and you can make it a tessellation. Doesn't really matter, like a subdivision of 3. That's fine. Looks good. That's a sphere. And then if you right-click, we'll just do a quick item mask. So under Shade, create item mask. That's just giving us an item mask in the shader tree to make this sphere semi-transparent so we can look through it. So I'm going to bump transparency up to like 75% or so. And if it doesn't show up in the viewport, just press O in your viewport and make sure under active items that, or under visibility, that use shader tree is selected. So there's use shader tree, and so we've got a transparent sphere there. And you see that on the edge of the sphere is our endpoint locator. All right, so here's where we're going to do some work. We're going to parent endpoint to Z, and then I'm going to parent Z to Y, and I'm going to parent Y to X. All right, that looks good. And then I'm going to select X, Y, and Z, all three of them. And I'm just going to, well, actually, let's do it like this. We'll just do one at a time. Let's do X. We're going to rotate, select the X rotation channel. Press S to set key. On Y, we'll set a key there at 0. And at Z, we'll set a key as well. And then let's go up to frame 210, like we had before. And going backwards, let's make Z like 180 degrees. And let's make Y like negative 270, and X, let's just make it 360. Okay, some pretty small numbers. And what you see happening is this endpoint is sort of being whipped around the edge of this sphere. It's not connected to the sphere. The sphere is there, just there for visualization purposes. But because this is, half a meter, the radius of the sphere away from the center, and it's just being sort of whipped around, but as these things do these random rotations, it just sort of is moving around the inside of the sphere, right? It's always staying 0.5 meters away. And so what if we go in here and we take our endpoint and we plug that into our locators to array? And we already have the start time set up. It's set to mode single. And so we're going to get our numbers here. And then if I plug that in to create polygons, what do I have but a curve drawn on the inside of the sphere, all with just these random animations I put in. Which is pretty nice, right? If I were to make this, I would have had to have, created a sphere and then turn on snapping or something and start drawing it. Here, I just let the random magic do its work. But that's not enough to get this, right? We want something like that, or like this. And so that's a lot of curves. That's a lot of rotations. So let's bump up everything. So I'm going to turn my scene, instead of 210 frames, let's do 3,000 frames. Sounds good, I guess. And then on our X, why don't let's take X, Y, and Z locators here and take a look at our motion graph. And so here they all are. Also, you want to set these to, instead of curve, we really want linear. We don't want any easing in, easing out. Let's just go linear. And select that keyframe, move this out to 3,000. And then I'm just going to really crank up my values like crazy. So let me just drag all the way out here. So at 3,000, I'm going to... actually, let's pop open our schematic real quick. And let's change our create polygons, or our locators to array maximum frame to 3,000, just so this is all showing up here on the screen. And then we can just stay there. We'll head over here. And X, instead of 360 degrees, let's just go like 36,000 degrees, right? So lots of whipping around there. On Y, let's go like negative 27,000 degrees. And on Z, let's go like 22,000 degrees, something like that. And now we've got like a much more randomized sort of look, and this drawing around the outside of the curve or outside of the sphere is really sort of starting to look like, one of these images that we're trying to get. And one of the things that we'll notice is that all the curves are drawn in the same plane, right? So if this was a tube, it would be intersecting each other constantly because they're all in the same plane. And really, like if you're winding up a ball of twine, you start really small and you keep winding and winding and winding, and it gets bigger and bigger and bigger with volume. And so we're going to simulate that by doing a slight scale up as we are doing this sort of winding. So we'll just take our X right here, and we'll start, let's end at 100%. So at frame 3000, I'm going to Shift R to set a scale keyframe there. Now frame 0, if I go all the way to 0 here, and you can see that it's starting in the very middle and slowly going to be getting farther and farther out from the center. So if I just sort of drag here, eventually you'll see that locator like making its way towards the edge. You'll see let me just select it actually. You'll see this locator slowly making its way towards the edge as it keeps rotating around the sphere. So that's nice, but honestly, in order to fill up a ball of twine, if I just hide the sphere now, if I were to fill this entire thing up with curves, I would have to have it rotating around, hundreds of thousands of times probably. And so we're going to do a little cheat to really fill in the blank spaces in the middle. So instead of starting at 0% and scaling all the way out, let's start at like 95% or something like this. And this is where, if you're really trying to make sure nothing ever intersects, and I don't think that it really matters because it's going to be really hard to tell, but you want to take, if you really want to do the math on it, take like the width of or the radius of your tube that you're going to have, and then get an idea of how many loops around you're going to do, loops around the sphere you're going to do, and as it slowly increases in radius, it has to increase enough in radius per loop so that whatever the minimum radius of your tube is. So if your tube is a millimeter, it's got to increase like at least 1 millimeter every spin around the globe, so to speak, so it doesn't intersect. But I'll leave the math to you. I'm just making art here, so I think this is close enough. And so here we have a pretty dense bunch of curves located all around the outside of the ball, but we need to fill it in. We want something really dense, like this or like this, and we're not going to get that by just rotating it around a billion times, right? So let's do a little bit of trickery. I suppose you probably run out of RAM, but let's do a little bit of trickery to get that to fill in a little bit. And I'm going to do it with replicators. You could do this a number of ways, but I'm going to go replicators. And so bringing up my schematic again, we'll just add the replicator down there. And then for a particle generator for the replicator, I'm just going to use exactly that, a particle generator. So right there, little green guy, and drag him in. We'll hook these guys up. Particle generator goes to particle source, and then my geometry here goes to the prototype. And of course it makes this crazy array because that's what the particle generator defaults to, is a 4x4x4 array, and that's not what we want. So I'm actually going to hide my original geometry and these locators. Whoops, nope, need the replicator. Hide the locator. And I don't want array, I want actually linear. And so there's my linear particle generator. And let's just make the y and the z 0, so we have a nice straight line here. And then, let's see, let's make it, I don't know, like 16 or something. And so we got quite a few of them. And we're just going to nest these together. If you look at the scale, if I highlight XYZ on scale and in item mode press C for channel haul and drag, you can see that it does this sort of sequential scale, right? So it doesn't scale them all, it just scales by particle ID. And I want to scale them down a little bit, and not a ton. Like if I go all the way down to like 96, the way I guess it works is this one is 96 to that one, and this one is 96 to that one, and this one is, after a while you get pretty small. So I don't know, like 98.5 or something kind of like that. So they're all sort of going to be nested in there. And then we can also rotate them around. If you use step rotate, and on Y, actually you could rotate all directions, I guess. So maybe like 25, 33, 66, I don't know. But at the end of the day, you're going to turn length to 0 on X as well. So length is 0 everywhere. And it's just doing this. You can kind of see them nested in here. It's probably this blurry mess on YouTube, but we're just nesting these guys 16 times like Russian dolls, and they're sort of scaling down a little bit each time, and they're also rotating around each time. So it should look pretty cool when we render it. So let's give it a shot. I'm actually going to render in Octane render because it's a little bit faster for me. So I'm going to just go to an Octane viewport here, although you can render in MODO as well. Just make sure on your original geometry you go over to curves and make sure that render curve is on. And then I'll just go with like a 1.5 millimeters or something really, really nice and fine like that, and fire up Octane render, and there you go. Like, pretty good. Now you'll notice Octane render actually just renders really coarse curves. It only renders from point to point, and so if I hide my replicator and look at my original geometry and turn on verts, you can see there's not a ton of verts. Like, there's a lot of space between them. And so Octane just renders kind of straight in between each vert. And so I need to resample this if I'm rendering in Octane. Although in MODO, if you're rendering in MODO, you don't have to do this step. But if you want to add a deformer to it, you'll probably want to do this step anyway. So let's go ahead and do it. And let's just add a curve rebuild. And so curve rebuild. And what you want to do is not point count, but exact distance. And we'll do a point every like 3 millimeters. And so that gives me a lot more points in there. And it's a lot smoother. And when I turn that off and turn my replicator back on, it just looks, you know, really dense. In fact, if I go back to my original geometry and bump up the radius of the curve just a tad, maybe like 0.025 or something like that, it's looking pretty full in here. So at this point, you know, if you're seeing through your big ball of yarn, then you can add more replicators, you know, add more particles in your particle generator. And so here I've got whatever I had 16, you know, I can double that to 32 or something, and it's, you know, filled in pretty nicely. You can also adjust the scaling of that original locator. So if you go back, we can actually just look at the scale XYZ here, and scaling again. Let's make it linear instead of smooth. So if it's linear, there's going to be, you know, just you know, like the same number of steps in between each as this thing is scaling out. It doesn't ease in or ease out. But you can go into the beginning here. Instead of 97, you can start at 98 maybe and get a little, you know, fuller towards the ends. Let me just refresh Octane there. And, you know, kind of thicken it up a little bit. But that's basically what you're doing, is just playing with these numbers now and getting something that you know, are happy with. And then you can go in there and shade it and make it look like spaghetti or whatever. I'm actually going to I'll do one more thing. I'll show you how to add sort of some random variation in here. And so, again, if we look at hiding the replicator, if we look at our original geometry, and, you know, it's got a lot of points in here now with the curve rebuild. These are it's all black because of the vertices. So if I turn off curve rebuild, there's the vertices. If it has a new vertice every 3 millimeters, then it looks like looks like that. Lots of vertices, but that's okay because we actually want a lot. So if let me pause Octane here. So I add a, you know, we could just do a push mesh operation and distance of like 0.05 or so, and you see it sort of pushed out. If I turn this off, you'll see it sort of pushing out like that. Set to vertex. But what I want to do is add in the tool pipe here, add a texture fall off, right, like that. And then let's just add some noise to the texture fall off. So just noise, and MODO's got a ton of noise. So you can do some weird, like cute, you know, like checkerboard and get just you know, distorted that way. But I'll just go with noise. And there, you know, you can see a little bit of noise going on. If I turn push off, turn it on. The thing is, there's not enough verts in there right now to really enough resolution of vertices to really pick up all this noise. In fact, the noise I'm gonna turn it down to about 0.2, so it's a little bit smaller frequency on the texture locator there. But then let's turn back on our curve rebuild, and this will really highlight, you know, the noise in the push deformer now. And so we turn off vertices, and we just sort of look at it front view here. So you can see there's quite a bit of noise, and, you know, we can, you know, increase the push distance a little bit if we want to, or change and we'll just do 0.075 or so like that. And so get a little more of a push, a little bit more noise in there, a little more sort of jagged, organic looking. And then on our noise locator, I suppose we could make this even smaller, like 0.1, and get a little more frequency in there. So yeah, it's looking pretty organic now, a little bit like lightning or something. Just look at Octane here and maybe push in a little bit. Like so. Looking pretty good. It's sort of like plant roots, maybe just because it's green. I don't know. Well, something going on there. And then, yeah, I'll just turn back on our replicator. And so now it's sort of a fuzzball. And it really filled in some of those holes as well with all the extra variation going on there. So that's kind of how you do it. I mean, then you can go in and really sort of mess with the curves and do whatever you want in terms of shading. Which is cool. And because there's only a handful of curves in there, you can shade along the length of the curve and do some other fun stuff. Maybe we'll just do that real quick in Octane just for the heck of it. So let me just, do I have a item mask for this guy? I'll do an item mask for original geometry there. And Octane just likes to always be refreshed when you do that. And then I'll just do, if you're not an Octane person, here's how Octane works. So I'm just doing an Octane override. And then Octane has a nice little gradient node that's basically the MODO gradient one. So new texture, we'll just do gradient 2, and that gives us sort of a MODO gradient in there. And then I really wish we had the nice list drop down for gradients that MODO has, but we don't. So we've got to go over here to, what is it called? W coordinate, I think, is along the length of the curve. We'll plug that in. And then we'll just adjust our Octane gradient here, and I always pick some, some kind of complementary colors. Maybe we'll do red and, we'll do red and white, sort of a candy cane. Why not? Maybe kind of push in the red and do another white. Mix we'll just sort of, another red, get a white in there, whitish. All right, looking pretty good. Is that white? Let's make that red. White and white. Okay, looking okay. Let's make it stepped. Maybe like that. No, not like that. Like this. Stepped. There we go. All right, getting there. Looks like a big ball of yarn or something. I don't know. Kind of cool. I'll live with it. So that's how you make the ball of yarn. So this one's gone pretty long, so I guess I'm going to have to do a second tutorial for the head, and I'm kind of on a roll here tonight, so I'll just make a second one right now and put them up back to back, I guess.
Yum, yum!